So our first lesson is on limits with an introduction with tables or finding limits numerically. The first question that we have to answer is, what is a limit? And the limit is a value a function approaches as the x values approach a certain value. So first thing we want to do is we want to kind of differentiate the difference between a limit and a function value. So for example, if I have a graph, it doesn't really matter what the graph looks like, and we'll call this point A, and we'll call that f of A, and let's just say that that's a 3. So the function values we are familiar with. We are familiar with saying something like the f of A equals 3. That's the function value at that specific domain value of A. Now on the other hand, we have this thing called the limit as x approaches A of this function, and we'll call this function f. So the limit as x approaches A is not what that point is, but what does that point get closer and closer to as we get closer and closer in towards that A. We don't need to actually get to A, we just need to get closer and closer and closer to A and find out what that value is. So in this case, they're actually the same. But the function value is the point at that spot. The limit is what it gets closer and closer to. And you'll see in some of them farther examples where those things might be different. So that's what we just got done saying with the limit notation. We have the limit as x approaches a value of a function. So that's what that means. Now there's also the left-handed limit, and there's also the right-handed limit. So the left-handed limit we write like this: limit as x approaches A from the negative side of f of x. And the right-handed limit we say the limit as x approaches A from the positive side of f of x. And if all of these things are equal, then this limit here in the middle exists. If it doesn't, then the limit would not exist. So let's look at some examples of when limits exist and when they do not exist. All right, so for example, let's just draw another quick picture. Let's say we have some sort of function that has a hole in the middle, and we'll call that A. And let's just call that value right there 3 to stay consistent. So when we're looking at the limit as x approaches A from the negative side of this function f of x, what we need to do is we need to come closer and closer and closer to that function from the negative side and see that that gets closer and closer to 3. Next thing we might want to do is find the limit as x approaches A from the positive side, which in this case we're going from the positive side and getting closer and closer and closer to A from the positive side. In that case, we're also getting closer to 3. So because those two things are the same, this limit to A in general exists, and that limit is 3. A second example you might have is a function that looks like this, where you might have a jump. It's called a jump discontinuity, where you've got that graph like so. And in this case, the limit as x approaches A, we'll call that 2, we'll call that, let's just say -1. The limit as x approaches A from the negative side, in this case, is going to be from the negative side, we get closer and closer to 2, and from the positive side, so the limit, the right-handed limit, as x approaches A from the positive side, in this case would be getting closer and closer to -1. And because these two values are different, the limit as x approaches A in general of that function does not exist. Let me write that out all together. It does not exist. Or in other words, DNE, does not exist. So there's a basic understanding of when a limit exists and when a limit does not exist.